Hello pre-calculus students, this is Unit 8, Exponents and Logarithms, and after we do a short warm-up that's going to review everything that we've done in days 1 through 3, then we're going to solve some log equations. So in number 1, we have a rational exponent, and you need to remember that the top of the exponent is the power, and the bottom is the root. So we're taking the fourth root of 81, and we're raising that to the third power. Well, the fourth root of 81 is 3, because 3 times 3 times 3 times 3 equals 81. And we still need to raise that to the third power. And that gives you 27. 3 times 3 times 3 is 27. In problem 2, we have to simplify inside the parentheses, and you also have an exponent outside the parentheses. And I think it's easiest if you simplify inside first. So you're going to take anything that has a negative exponent and you're going to move it to the other part of the fraction. So in this case, I would have a to the 1/3, and that would move to the denominator because it was negative. Moving it to the denominator makes it positive. And I have a to the 1/6. I have a b up here. This b to the -2 is going to move up here and become a b squared. And then the c to the 5, that can stay where it is. Okay. So then you want to combine. When you're multiplying, you add exponents. So b times b squared is b to the 3rd. And I still have c to the 5th. And then on the bottom, I have 1/3 plus 1/6. With a common denominator, this becomes 2/6. So I have 2/6. Let me just change color so I can add these fractions. So 1/3 plus 1/6, 2/6 plus 1/6, which makes 3/6, and that answer can simplify to 1/2. So the a is going to be to the 1/2 power. All right, and this is all being raised to the -2 power. So then when you have a power to a power, you multiply your exponents. So I'm going to get b to the -6, c to the -10, and 1/2 times -2 is -1. So all my exponents are negative again, which means they're going to all move to the other part of the fraction. So the a comes to the top, b to the 6, and c to the 10 comes to the bottom. And that's your final answer. All right, to evaluate a logarithm, you say that it equals x, and then you rewrite it as an exponential. The base of your logarithm becomes the base of your exponential. The answer of your logarithm is the exponent, and then this number goes over here, 125. So 5 to some power is 125. Well, I know it's not 5 to the 1st. 5 to the 2nd equals 25, so it's going to have to be bigger than that. So the answer is 3, because 5 to the 3rd power is 5 times 5 times 5, and that's 125. In problem 4, same thing, right, equals x, and then you have base of 3 to the x equals 1/9. So some exponent's going to change it to 1/9. Now, you know that 3 squared would give you 9, and in order to put it in the denominator, it's going to be negative. So instead of x being positive 2, x is going to be -2. That will flip it and give you the reciprocal. In problem 5, it says to rewrite it in log form. So you write log. The base of your logarithm is the base of your exponential. And then these two numbers switch so that this is 8 and this is -3. And the answer to the logarithm is always the exponent. All right, to simplify here, we need to use our properties. So they're all ln, which is good. If you have a 5 here, that can become the exponent here. So I have ln of a minus 2b plus ln of y to the 5th, and then that 2 can also go on the x. So that's going to be minus ln x squared. Now, two logs that are being added, you can multiply those. So it'll be the log of a minus 2b times y to the 5th, and then a log that's being subtracted, that can be divided by, so it'll be over x squared. So it becomes a single logarithm. All right, so those were your warm-up problems, and now we're going to go to solving log equations. The steps for solving are to isolate the log. So for example, number 1's already isolated, but number 2, you'd have to isolate this log here. Then, if you can rewrite it as an exponential equation, or you can do something called exponentiating both sides. So I'm going to show you real quick what that means to exponentiate both sides. It means take each side and make it the exponent. So you take a base, and you want to take the same base as your logarithm, and then you create that base on both sides, and then this becomes the exponent. And what happens when you do that is that 2 to the log base 2 cancels out, and that gives you x equals 2 to the 5th. So that your x equals 2 to the 5th, which is, of course, 2 times 2 times 2 times 2 times 2, which is 8, 16, 32. Of course, you can achieve the same thing without exponentiating if you're just rewriting. So if you're just rewriting, your base is 2 to the 5th equals x, and so you still get 32 regardless. All right, in problem number 2, you need to isolate the log first. So we're going to subtract the 8 from both sides. You have negative 2 log base 5 of negative 4x plus 33 equals negative 4. And then divide by negative 2 on both sides. So log base 5 of negative 4x plus 33 equals positive 2. So then you can either exponentiate by doing 5 to the 2 and 5 to the log base 5, or you can rewrite as an exponential. So your base is 5, your power is 2, and that gives you negative 4x plus 33. So I have 25, and subtract 33 from both sides. I get negative 8 equals negative 4x, and dividing by negative 4 I get x equals 2. Okay, in problem 3, you can either say that log base 5 of 5 is going to cancel because it's the same base and you'll have 2x plus 7 equals x, or you could rewrite it and you would have 5 to the x, base to the x, equals 5 to the 2x plus 7, and you know that once the bases are the same, the exponents have to be the same. So subtracting 2x from both sides, you get negative x equals 7, and dividing by negative 1, you would get x equals negative 7. And if you have log base 7 on both sides, you can raise 7 to the log base 7, so you can exponentiate both sides and cancel them. So you get x squared minus 5x equals 6. And to solve a quadratic, you need to make one side 0. And the numbers that multiply to negative 6 and add to negative 5 are negative 6 and positive 1. So x minus 6, x plus 1. So you have x minus 6 equals 0, x plus 1 equals 0, and that gives you 6 and negative 1. It says to check for extraneous solutions because remember that this part in the parentheses has to be greater than 0. So 6 squared minus 5 times 6 is 6, that works. Negative 1 squared, that's positive 1, and then this is going to make a positive 5, that's also 6. So neither answer is extraneous, you do have 2 solutions. And then in the next one, we're going to need to combine using properties. So remember, if I have a log plus a log, I can rewrite that as the log of the quotient. And that would be x times x plus 3. And now that I have a single log on both sides, I can exponentiate like this and cancel those. So x times x is x squared, and x times 3 is 3x. That equals 10, and then you need to make one side 0 so that you can solve it. So you need the numbers that are going to multiply to negative 10 and add to 3. That would be negative 5 and positive 2. Nope, I got those mixed up. Positive 5 and negative 2. So when you set those equal to 0, you get x equals negative 5 and x equals positive 2. So you want to check those back in here and make sure that they don't make anything negative. Well, first of all, this is log base 2 of x. If I put negative 5 in there, that is going to not work. It has to be greater than 0. 2, though, will work for both of them. So this answer is extraneous and this answer works. For this one, if you subtract 2 logs, it's going to be the log of the quotient. So that would be 2x plus 3 over x. You can still exponentiate. So your base of ln is e, so you want to raise them both by e. And then you have 2x plus 3 over x equals 8. So I'm going to multiply by x on both sides. And you have 2x plus 3 equals 8x. Subtract the 2x on both sides and you get 3 equals 6x. And divide by 6. So x is going to equal 3/6, which is 1/2. Now plugging it back in, 1/2 goes here, that's fine. If 1/2 goes here, this also is positive. So 1/2 is just fine as an answer. So for the last problem, what I want you to do is try this problem and then bring your answer to the teacher and see if they got the same answer that you got.